Okay, this is, I guess, a special request, which will go in the reference section, I'm thinking. And this has to do with lesson 37, I believe, which I've managed to reconstruct here, looking through old archives. And I think this is approximately where it was. And what I'd like to do is just go ahead and make a do as I said, hide the node, the internal node structure from the user of one of these list type managers. Create a manager for lists wherein one can use the list functionality without having to know the details about these structures. One retrieves, generally speaking, in the C world, Windows especially, handles to things, and the handle is not a pointer necessarily. It could be, but it doesn't have to be. Although its type is a type of pointer to void, that's irrelevant. And the handles are retrieved and maintained by the user of the object. A window, for instance, contains a handle to is associated with a handle to itself, and operations done on Windows are done by passing the handle to various C-style functions. So I'm going to have a look at this now. I'm going to pause this here and see what I can come up with that is easy, understandable, not too in-depth, and explains the idea. Okay. Hello there. This is me again. Yes, I already gave the intro to this. I don't know if this completely answers the question, but I thought I'd give at least a demonstration of a purely C linked list type object manager, let's say, wherein none of the bad things that you were able to do with access to the internal data you can do with this. Now this thing returns what I call handles. Okay, now I've just taken this from Windows.h. This is a dummy struct, doesn't have any meaning. Probably, I'm not sure if the compiler will complain. In C, let's see now. That's a handle to list. This is a handle to node. Suppose I put a handle to node here. It might complain. Should. Right. Okay. Now it's just a warning as far as C is concerned, but the idea is correct. Incompatible types. That's what we want. So a thing that adds data to a list takes a list type handle and some data of any unknown type. This function is designed to create a list. It returns another handle type object. And as I run through this, you'll see that these handle values needn't and shouldn't bear any relation to pointer type value. So here is our H list. Okay, that's just a number. This number is definitely not a pointer value. It's too small, basically. It's just some sort of index internally maintained. Now this is C, so I have to declare everything up front. Now what I'm doing here is the program here has that long, or something like that, long command line, and I'm taking, I'm making a second copy of each argument and adding it to the tail of this list, which is given by this. Now this thing actually returns something. It doesn't say what it returns. You want to see it. It returns a node. Returns a handle to node, I should say. Well, I can use this. And I could print it out if I like. You know, as far as this type, it's as this declaration. It's a little bit difficult to read, but given whatever the name is, this defines a type def, which is a struct type with some dummy variable, and the star here means that the H types are pointer types. So that means 32-bit pointer type value. So let me go up to here again. And this is the value it gave. Now you might think that that might be a pointer to memory. Indeed it is not. Here it is here. That's just garbage. You will note that the last 4 digits are the same last 4 digits as in our handle to list. And so will be every other node added to this list. They will all be numbers of the type some index, and the last 4 digits, the index identifying the list. So we can see that these items, by virtue of their identifiers, know which list they belong to. Okay, I think that's almost all of them. Okay, so that was a whole bunch. Now, in order to get the data out, since these are pointers and we can't access the data, there's nothing here in H node to give us the data out. And I'm thinking it again. The first node I retrieve is that. To get the data out, there's a function here called getNext, which takes a pointer to a node, pointer to a handle to node, which will be updated following the retrieval of the data associated with that node. So the next time through, H node will be ready to get the next piece of data. And here I've printed it out. So it's breaking it up, just as before. these are the strings that we added to the list, and we added them to the tail of the list, and so they're coming out in the same order they were added. If I get rid of this print here, here's the printout. Okay, now at no point in the program are we able to do anything like fiddle around with what points where and what, list a node belongs to. In fact, we don't add nodes to lists in this case. We add data to a list, and we're given a node. So we don't have anything to do with these nodes as far as adding nodes to lists. We can retrieve them from lists and use them, but we can't add them to a list, and therefore we can't make circular lists or delete something twice, and those various other problems. I also add head function, so that adds to the head of the list, and the result of that is the printout is backwards. You'll notice that add tail didn't return different values for the node, node added. I should have said head. And I just do, I had tail and now I'm doing head, sorry. When we add head, they print out backwards, and add head doesn't return anything new. The return value is kind of meaningless, but essentially it returns the handle to the first node in the list. This function does, and so does the other. Is that right? Yeah. And since they returned that, since the I'm adding to the head. I don't know. It completely doesn't matter. These might as well be void functions because you can't do anything with these nodes. You could call get next, I guess. The get first is in fact that number, same number. So add head is always returning the first handle to node of the list, whereas add tail is returning the last, and the last is changing as we keep adding things to the tail. In terms of handles, but we don't know what a handle is, so it doesn't really make much sense to rely on it. Let's see, this originally was the tail of the list, and the tail of the list was this, right? And it changes by the way I've implemented this. Now, how have I implemented this? It's really a hack. I generated some random numbers, okay? And I gave each node an index and a data and an X pointer. I defined an array of pointers to node stars and a maximum number of lists that we can make, and that array will contain actual pointers to data, And the way I'm inventing a handle to return is each list is identified by an index, 0 for the first one, turns out. And then the ID, so if it was the 10th list, it would have an ID like the 10th number in this list. And the individual nodes, I've given identifier numbers, and I use that same array to generate another kind of random looking number, which goes in the top part of the thing returned, which is a meaningless number as far as the outside world is concerned, but not meaningless inside here. Get next. Let's see. I'm extracting the index where I'm going to find the head of the list, and I'm extracting the index of the node that I'm searching for, which is in the top 16 bits, and doing a kind of walk through, locating the node in question and returning its data. And that's about that accomplishes the data hiding and list. I didn't implement delete or insert or whatever, but that's something you can do on your own if you're curious. You don't have to do anything like this. This is intentionally made convoluted so that it would be easier to see in these printouts that a handle value is simply an identifier. It has nothing to do with pointer necessarily to any data. And Windows is the same. When you create a window, there's a function you called create window. And that returns, the help file works, something called a handle to window. Okay. Now that is not a pointer of any sort, and you can't extract a structure from the numeric value of this hwind thing that's returned. You simply pass it back in to retrieve things about the window, just as I'm doing here. If I want to get a node, I pass in a handle to list, right? Or if I want to add something to my list, I pass the handle to the list in and the thing I want to add. If I want to get data out, I pass in my handle and the data comes out. But I don't have direct access to that data. It's through some manager that knows how to turn this handle into an internal pointer that we have no business knowing about. I have a book, in fact, that you might be interested in. You can find this online, or I can make it available somehow, where the handle, the discussion here is about information hiding and handles and so on. And this person spends a lot of time looking at the handle and seeing what can be extracted, and is able to come up with some some information about how the handles relate to the objects that they describe. Okay, now first the benefit of the fact that we're using handles is obvious. Now pointer versus handle. Anyway, at some point, he comes to this. Okay, a handle provides nearly perfect abstraction information, hiding in protection, but also frustration because the internal representation of the data is not documented on purpose, of course. Now, this leads to certain problems, and in particular, some that I've mentioned. Resource leaks, for instance, are not apparent. We don't know the representation, so we don't know how to check for errors in our code in freeing. Should we be freeing a handle? Should we not be freeing them? Are some certain types of handles more processor intensive to use? How should we write an efficient program when we have no idea whatsoever about the implementation? Like he says here, with implementation completely hidden, debugging is a big problem. My program displays garbage after 5 minutes, so I guess maybe there's a resource leak. But where is it? How do I fix it? Right? How do I find the problem? Then there's something called bounds checker, and this relies on spying techniques and so on and so forth. And it becomes a hack just to debug your program. And then he goes into actually starting to decode and find out the internal representation of data in Windows. Okay, and it's quite interesting to look at. And what comes out of it is a lot of understanding. Okay, well, if you want to look at this book, I don't know. It's probably, I don't know if it's certain it's got to be out of print by now. So I doubt that there's any problem to copyright. Anyway, I hope that helps. Okay, see you.